Hi everyone, my name is Mathieu. I'm a researcher here at ELSI, and today I will tell you about lunar science and why you should care about it. So if you look at the moon in the sky, it looks something like this. This is the near side, and you have those two regions that are very different. Lunar volcanic flows and old crust. If you could look at the far side, then it would look something like that. Mostly like this type of crusts, and this is very different. And I'm saying near side and far side here, which is important. It's very different than bright side and dark side. The reason is if you take the sun here, for instance, and the Earth orbiting the sun, not at scale, if the moon is here at some point in the orbit, with this point looking at the Earth, later in the orbit it would look here with the same point still looking at the Earth. So this is the near side on both cases, but in that case the near side is bright, and then here the near side is dark. So this is not to be confused, and the media sometimes make the mistake. The reason why it's interesting to look at the moon is that most of the surface is very ancient. There is no erosion basically. There's no atmosphere, so there's no rain either. There is no wind at the surface, none of this, which means that most of the rocks are very old. So if you look at the number of rocks that can be found on the surface as a function of age, for the Earth it would look something like that, whereas for the moon it looks something like this. And this is very important because this tells us that by looking at the moon, we can learn a lot about this early period here, where the record has been mostly erased on the Earth, and we can learn from it on the moon. And one of the things we learn from this ancient crust here at the surface is that the moon probably started mostly molten. So if you start in that case here, where everything is just molten, and then you start crystallizing, you end up with a core. The mantle starts to crystallize here as well, with a crystallization front going towards the surface. This is still mostly molten. And then you start having this crust here forming at the surface, which is pretty much what this crust is here. And this magma ocean phase is very important because it's a situation where most of the exchanges between mantle and molten material, crust and atmosphere happen, and that plays a very important role for planetary formation. However, an important point here is that most of the information we have about the moon comes from samples that were obtained in this region roughly. This is where both the Apollo and the Luna mission landed, and it is, as you can see, a very limited space at the surface. We have some ideas about the far side, of course, from remote sensing, but also from meteorites that we believe come from a more uniform part of the lunar surface. But we do not have a picked sample from that side. So luckily, more missions are starting to be developed for this, and recently a robotic mission landed on the far side, right about here. This is the Chinese Chang'e 4 missions. So hopefully there will be more coming in the future that can tell us much more about the difference between near side and far side of the moon. So thank you for watching, and please stay tuned.